A very good morning to everyone, and thank you all for coming for my presentation. I am Brianna Rajan, and I am a student here at ASU. Just the other day, for one of my lectures, my professor mentioned, please do not use ChatGPT for reference. That's how dependent we've become on the newest invention or the newest helper in town, could say so. For that, that is when I started thinking, how dependent are we on LLMs, and are LLMs nearly as smart as humans? Because we humans are really smart. And so, with the new applications that are building right now on top of these LLMs, this idea generated wherein why can't we use a methodology or an approach that we use in usual organization to imbibe the same workflow to how LLMs work. And so for that, I did conduct a few experiments, and I did receive slightly better responses with this kind of a workflow that we usually use in an organization. That later developed to this idea, an organization of LLMs. So the traditional workflow structure in an organization, especially when it comes to something like query handling, is typically involves different layers or different stages that is usually dependent on the organization's the kind of query they assess, the kind of approach they take for it. For this entire presentation, let's all think about the way a query is handled for customer service. It all gets way more easier to explain that way. So it's usually the first step is receiving queries, collecting queries from customers, clients, whoever it is. What have you got to ask? Collection of those queries. It is then documented well, adding more details to it. When was this query received? What was the question being asked? What kind of contact information was that? Just to get a context about what this query involves. What kind of customer did ask this question? Where was he or she from? What kind of background do they have? What kind of purchase history do they have? All of those context is just collected for documentation, just so that the query itself has a lot more context when someone is looking at it. Then it comes to categorization and assignment. What are the questions asked in this query? What kind of departments or what sectors are these questions being asked to? And thereby assigning these queries and then routing them. So one query may or may not address multiple departments. What if one query has something like, I received so-and-so product, it was delayed, and also the quality was bad. So it addresses two different departments. One, the logistic department, who handles all of these delivery of the packages and stuff like that. And the other one's dealing with quality. So this categorization stage comes into picture where this query or pieces of these query are assigned to different departments according to the query. Then comes processing and investigation. Each of these departments then work on assessing the query. Here is when the initial context that we had about the customer, about the product, about the person's history comes into picture. The assigned team or individual thoroughly investigates this query, thereby gathering all the relevant information, conducting research, analyzing the issue in detail, and then an output is formed with the general understanding of the query. Then comes preparing the response. That each query should have a tailored response. A customary one may not look good to a customer. A very generalized one is not very appealing to any of us, isn't it? So the response can take various forms, just as the query. Could be an email, could be a phone call, or anything. And sometimes it is an actionable result. It could be something like, oh, this customer did not receive a package that was well packed, it was damaged or something. So it could be something like, I also need to alert another team to send a new package to replace the old one, or something of that sort that involves an actionable item. Then comes quality assurance and approval, wherein is the response addressing all of these user queries? If it was addressed to different departments, do we have answers from all of these departments? Is this a complete answer to the query from the user? When it comes to complex queries, it may also need a further level of approval, one more level higher, one more stage to go, especially when it comes to issues that require legal assistance. If it has some kind of legalities involved, it's very recommended and a very usual practice in most organizations to have one more level of approval just to make sure that we are well, the company is well in terms with the law. It adheres to all of these laws and it is never in trouble. Then the last stage for this kind of the process comes communicating it back to the inquirer, sending the response back to the inquirer. Here is your questions. Here is what we have for you. Here is what we are doing for you. Then comes resolution, improvement, and compliance. After a response is sent, then there's a follow-up feedback. Are you satisfied with the response that you've received or the service that you've received? Now, after we get this feedback is again documented. Then there's a whole feedback loop that goes in, informing all of the parties that were involved in framing of the response as to how the feedback is, how satisfied is the customer, how good is your response, how well did it answer the queries, do they have any further queries, and such things. So putting it all in a nutshell, we get a query from the user or from any party, categorize it, then there's processing and investigation involved in each of these categories or departments. Then there's a whole response preparation side, wherein a well custom made response is being generated to each query. After the response is generated, it first undergoes a general quality assurance check. Then there's an approval, if applicable, from the other departments. After it is being given as an output to the client, there's a closure and a follow-up documentation that is conducted. There's always continuous improvement and training done with respect to the feedback received from the user. This is how a general query handling happens in an organization. In most organizations now, LLMs are being used to take over this process, to just handle the query. Most customer service chatbots that we use now have LLMs. These LLMs also have a set of document that they have about the information about different products. Let's think about a commercial e-commerce site. So maybe we are selling different products. So the chatbot has a database about information of all of these products, the general guidelines that the company follows, the general structure of workflow, or something of that sort. So the customer service chatbot is equipped with enough information as to answer the query at one shot if something is being asked about a product, about the usual company's policies or anything of that sort. But let's take the case of OpenAI's ChatGPT or the GPT 3.5 Turbo that they have made available. Most usually, when programmers build a chatbot of this sort, what happens is there is a search methodology being applied. So after the user query is being taken, you just go to the document, search for the context that most nearly matches the user query. Then there's this context, the text paragraph that you have, the text or whatever form of information that you have. So there's document, the user query, general context information about the user. That is all being sent to the LLM. And then the LLM is asked to craft a response. When all of this is done in just one shot, the LLM is being forced to have multiple roles being played. The LLM has to search this query, find an answer, and then output it. Whereas in a general organization workflow that I showed earlier, when it is done in different stages, in different steps, the accuracy is higher. Chances of getting a false output is lower. The quality of response gets better. The open agency model, the architecture of open agency, it represents a paradigm shift. It just refines how LLMs or AI in general can handle the complex tasks. It involves multiple generative models having different roles, working together to perform different diverse tasks. Just like we have in an organization, when people have different roles, are assigned different tasks, and they all work in harmony and create a good output. So The whole idea behind this concept is to blend in both of these. Use the power of LLMs to understand, to craft responses, to understand text and output meaningful text, with the collaboration with having specified or more educated LLMs, each in different fields. The key components of open agency model involve generative models. They have a variety of proposals or responses being generated to prompts. Then there are critics that help select the proposal which aligns the most with the user query in the case of the customer service chatbot that we were thinking for. And there are agents that are responsible for executing these proposed actions. So in this case, there are a set of LLMs working to generate different kind of outputs. Then there are critics who evaluate these outputs and select, oh, this one looks the best. And there are agents who then activate this plan of action. Just like I mentioned right now, there are critics who assess each of these generated outputs. So in case of the customer service chatbot, it could be said, one of the generative models said, oh, we could first talk to the logistics, then go to the company who manufactures these goods, have different plan of actions for each of these queries. The critics could then assess as to which of these could work better, and then the agents execute each of these in parallel. Comparing to how it works to the traditional workflow in an organization, the query reception could most often be done using a software application. Then categorizing could be done by LLMs. So it could be something like, the prompt could something be like, you are an LLM designed to categorize different queries into each of these categories. These are the list of categories that we have. Your task is to identify which of these categories the query belongs to. Then processing and investigation could lead each of these query to particular teams, wherein each team or each LLM is equipped with just enough information about the area that they are focusing on, and not the whole of organization. This again helps in just distributing the information that they have, and thereby helps getting great results when it comes to searching each of these queries. So most often how these databases are stored is that we have vector databases. The query is then transformed to a vector, and there's a cosine similarity function that runs through and finds the most similar context as to the query. So when you have a huge database, the cosine similarity has to go through all of these. When the database is smaller, we're more constrained, we're more particular about a subject, chances of, or the efficiency in fetching right context for the right query goes up. Then there's response preparation, wherein you have the context, you have the query, frame a response according to the query, that whole process happens. Then the response may or may not be viewed by a professional. This just enhances the accuracy, just ensures the performance as well, it's up to date. It also helps to keep an eye on if the LLMs has started hallucination. It just helps to ensure that all of these are just in place. This is a very optional step. Then there's quality assurance, where the critics come into picture. They just ensure that does the response answer all the questions in the query? Is it providing the context or the information just within the passage or within the information that is given? Again, keeping an eye on the generative power of the LLM. So when it's a borderline between generating from the context, giving the right response, versus the LLM starting to generate its own responses, which may or may not align with the organization's use case or the organization's principles. Approval from human professionals, again, an additional step. Then there's output to the client via the software application itself. The closure, the follow-up, the documentation could be done from a methodology called RLHF, reinforcement learning using human feedback. This continuous improvement helps, oh, this query appealed to this user. So this is the pattern that we could follow for the further queries as well. That kind of an input, that kind of an insight from the user's feedback. Continuous improvement and training, it all happens on the go. So with time, the bots help, the bots gain the ability to develop better responses. The role of diverse generative models are very important in this. Each of these LLMs are trained on the same pre-trained data, let's say. Like I mentioned earlier, if we have the example for using OpenAI's GPT models, all of them are pre-trained on the same data. They're just assigned different roles. This helps generate a range of answers, a range of proposals, and this helps that the model or the chatbot doesn't stick to one particular path itself. So if there's something coming up that is better, it learns to adapt itself to the newest in town. With new responses being created, with new feedbacks from the user, the system learns how to adapt to what is more appealing and to improve itself by its own. So it's all a cycle on its own without much of human intervention. Leveraging diverse critics and diverse agents. These critics are tasked, given the task of evaluating these LLMs, and this ensures that only the best is being delivered. This also ensures that there is a diverse variety being created and not the same kind of output is being delivered each time. It improves with time, with the human feedback, of course, and also with the choice it makes using these critics. And these agents are employed to execute the proposed actions. Each of them are equipped with certain set of information, let's say about a certain category, and they're all equipped with having a precise knowledge about that category only. So this avoids having one LLM to go through a whole bunch of information and having to do something. Like I mentioned earlier, it helps improve the efficiency. Now, the efficiency is also with respect to time. Some of these processes are done in parallel. So there could be one LLM generating one kind of response, while the evaluator is also working on evaluating the response that is already being generated. There could be a rubric-based evaluation done already, like are all the questions in the query answered? Does it provide enough information to all of the questions? How many tally these tasks which are independent of the other responses? So these are not like, is this response better than the other one? So there's no second response coming to picture. When it's a rubric-based evaluation that's done, it's just like, okay, this is a response. Does it meet these these criterias? That could be done in parallel. There could be multiple LLMs working in parallel to create diverse proposals. These could help improve the efficiency, get more creative or generative ideas to the system. And it also helps the query handling capabilities with adapting to what appeals to the customer with time, with each new query that comes into picture. And that's all about the idea. In general, so I'm working with Arizona Water Innovation Initiative. It is an organization that one of the modules in that organization is to help understand what misconceptions people have about water in Arizona. And one of the ideas that they're implementing is developing chatbots using these LLMs to identify most common misconceptions and then thereby provide solutions accordingly. So this is one approach that we employed for the chatbot. And of late, the performance has been really up. The response time has gone down. The answers generated are way more accurate in context, having generally higher uh, success rates with respect to human feedback. And that's all I had for this presentation. Thank you so much. And I'm open to any queries for anyone. Yes, please. Mhm. That's right. Another LLM, yeah. Yeah. Mm-hmm. So, which is where the human feedback comes into picture. If there's a lot of evaluation going on, thereby with time, the human feedback, we get more negative responses from the human feedback. So, which rewinds or like tries to help unlearn what you're doing. So, it helps go back with reinforcement learning. So, each time you have a positive feedback, it is an update to the model like, oh, what you're doing is right. Go ahead in that direction. When you Yes. So the reinforcement learning using human feedback gets the feedback from the user, and the model, how the model progresses is kind of controlled by this. So when the hallucinations get deeper, you get more negative human feedbacks, which then goes by and then helps the model to like stop going in that particular direction. Uh-huh. So the evaluators are one part of this is the whole RLHF part of it, which is a whole different model that works. And this is like reinforcing the model. So you have a positive point when you move ahead in the right direction, and negative point. Also, the human feedback is another input to the evaluator, another LLM, wherein it's like this response did not satisfy so and so criteria. Maybe it did not provide enough information about the product that I was asking for, or it provided wrong inputs about the product I was asking for. So, which is another, so there's two ways. One is using RLHF, the whole model that works reinforcing the model, and the evaluator LLM also works in parallel, just adding to the progress of the model training or the model's development. Yeah. Yes, please. No. So the human feedback is only with respect to the response. Am I satisfied with the response? The human is not directly linked to how the model or the intricacies of the model work. Yes, please. How much as in now, like, so for phase one, we did have instruction fine tuning done, wherein the model weights weren't touched. So model was intact and just these were done. So with phase one, we did get few answers which were question answer form for fine tuning the model to modify the weights. So for phase one, we just had the prompts were so given that you are so and so, your role is so and so. System messages were crafted accordingly. And in phase two, we did have enough data to fine tune the model. So we had different fine tuned models, each working in different roles. GPT 3.5 Turbo. Hmm. Yes, that's right. So we're just fine tuning or adapting the model to be educated in one particular field a little more. So could think of it like we're using the language capabilities of the LLM, and then we're using that to provide answers. I mean, we are using that to learn about the context or the information or the role that we wanted to play in. Hmm. Evaluation also works. For it to stop hallucinating, it's just evaluation and RLHF. Fine tuning helps get the model learn better about the information we wanted to learn. Like Fine tuning helps change the weight. When it's just instruction fine tuning, it's just I'm changing the prompt. I'm telling the model you are this role. So it has all of the pre-trained knowledge as is. Then it gets a message, or the prompt is like, you are in this role. This is the context you have. This is the query you've been given. Answer this query with respect to the context that I'm giving you, which is like instruction fine tuning, wherein the fine tuning process changes the weights a little bit, wherein this new knowledge is kind of added to the existing pre-trained knowledge. And the LLMs work better in answering these queries accordingly. Yes, that's right. So one more reason why this works so better was because LLMs in general work way better for monotasking when it's given just one task to do versus multitasking wherein it's asked to do different things. So when I'm fine tuning it for one particular task, it does cause catastrophic forgetting, which is like it loses its ability, part of its ability to do other tasks. So if I train an LLM to answer a question, you given a context, answer this question. If this is how I train it, and if I ask it to, let's say, summarize a text, it may not work that well. But when it comes to one task, it does really good, which is when all of having these roles or having different LLMs working different roles, just getting the proficiency in one particular role, they each work well than having one LLM do all of it. Yeah, that's right. Mm-hmm. Yes. So for the model that I'm working on, the first one is like checking if the user has malicious intent, since it's an open source, or it's a project that's available to the public. So most of it is like queries about harming people. It most of it the malicious queries are about harming people. So if you send a query that is about harming people, the bot should stop right there and say this is not something I'm supposed to answer. So the first of it is like checking if it's a malicious input. OpenAI itself has some moderation APIs, moderation call APIs, wherein the LLM is trained to identify if it's something that could potentially harm others or is in terms of harming people. Along with that, we have some more guardrails put up just to know the query is safe to be answered. Then it comes to having different all of these roles of LLM that I said. And then there's an evaluator model that just does the first level of checking. Does it answer everything? The critic is then performing to choose the best answer of all of them. And then we have the output being sent. Then the feedback is again reinforced to the model, and that's how it works. Could you please like, uh-huh. Yeah, 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 that's right. So there's one, um, depending on, so we are just modifying a little bit. So right now it's around 10 different LLMs that are being used. So all of them are not working at a time. Like depends on the workflow and how many of them are have to be worked in parallel. So depends on that. Yeah. Right now it's not up for the public. We're still in the phase of user testing, and then it would be up shortly. So welcome. Yes, please. So right now we're using most of it with OpenAI itself. So even when you're fine tuning the model is still with them. So I'm not very sure of how much of computing resources is required. So yeah. Yes, please. Yeah. Mhm. Yes. So one of the LLM is working on like, does this query have any pre-assumed data? So this is mostly in this is an LLM deployed in the instruction fine-tuning stage, since we did not have data enough to fine-tune the model and change the weights. So it's just like, does this query, does this person or does this query have any assumptions already? So some of them is like, since Arizona is already really in drought, how are we going to survive for the next 35 years? So this involves, I mean, this query in itself has like, the assumption that Arizona is deeply in drought. So identifying common misconceptions, some of which we have found is Arizona is too much into drought and we are going to have a shortage of water in the next 5 years. So this is a common misconception that we have identified so far. The other one is water in Arizona is not safe to drink. The water is way too hard to drink, and so it could cause a lot of health issues, which hasn't been proved medically or scientifically. It's still uh, scientifically, it is still in the realm of finding if there are any uh, consequences with respect to drinking hard water. But as of now, it has been proven to be safe. So this is a common misconception people have, that water in general is not safe in Arizona, since it tastes a little different due to the hardness. So we have another LLM just deployed to find the misconceptions of what people presume about Arizona, water in Arizona in particular. Yes, please. Uh-huh. So right now it's not open for the public. It's still in the phase of user testing and then still modifications being done to the project. But we gather data from the cities. So different cities in Arizona, gathering data about all of these cities, finding about water reports, water quality reports. So each city generates a water quality report every year. So we have that data being fed to the system. We have the the Salt River project data being fed to the system. And so uh, Colorado River. There are different projects being done with respect to Colorado rivers. There's a whole Department of Arizona Water that works with planning about the water resources. So we have reports from them that are being collected. So we have data from all of these sites, or all of these cities, I could say, which was collected for this project. So that is the data we've used to put it as an input. Phase one, as I mentioned earlier, was an instruction fine-tuned model, so which did not have any changes to the model weights. The model was as is from the chat from OpenAI's GPT 3.5. The model was as is. The prompts were so defined. So the answers to which the users upvoted were like, this satisfied all of my queries, and I think this is right. These answers, or these question answer pairs, were then collected for fine tuning the model. Since we did not have much of data available as to a question answer form of pair to fine tune the model later, we collected responses from the phase one to update weights in the phase two. And um, so we did deploy a software application wherein this bot was deployed to just to have an interface. And then it was just chosen, some users were chosen for this testing and having different answers, who also had knowledge about uh, the questions that they were asking. So if they asked about Salt River project, they knew about the project. So identify that the bot isn't hallucinating, the bot isn't coming up with numbers that are not correct. Most of them were employees working in, so it's a collaboration with different cities, and it's in a Arizona state project. So we did have employees also log in, check about it. And there were also other users. So I'm working with Professor Stephen Carradini. So some of his students also helped us do the project. So they already had information about the question that they were asking, just to cross verify with the answer, and then that's how information was collected. So when we were starting, we weren't so well informed about how LLMs work, so well educated about the um, the realm of LLM per se, I could say. And OpenAI could seem to be the easiest to go option, since with fine tuning, the model is kept with them. So we didn't really have to take care about the computational complexity, as you answered. That was handled by them. It was easier to fine tune with the API call to the model. So overall, it was a easy point to start with. So we are also experimenting with lighter weight models like Llama and Flanty 5 just to see how well it performs. So it's still in the um, training phase, or the still not at the stage where I could say about it. So we haven't evaluated the models yet. So we're still trying different models, but we started with OpenAI's GPT 3.5 because we had enough resources, enough documentation available about it to start with. And overall, it was an easy way to start. So, yeah. Um, I believe it should be up with the ASU's. I actually couldn't say that. So it's not right for me to say, yeah. So it should be up in some time. So we're still in the user testing phase, and it's not in my hands. So how it goes up is, yeah. Since May of 2023, this year. So most of it was the initial part did not involve LLMs. So it was mostly data collection part, wherein talking to different cities, gathering data, and having all of these logistic part. But with the LLMs and with the technicalities, I could say from August. So we're still in the fine tuning process, where we are still in the realm of like connecting newer queries, updating model weights, performing on those things. But we started once we had 1,000 question answer pairs. So 1,000 data samples, I could say. That's when we started with the fine tuning process. It is both iterative. So we do have like when we have one set of data samples, there are different epochs. So that way it is iterative. It is also done in phases. So we started when we had 1,000 samples. Right now we are near 2,000, 3,000. So with new samples, with more samples being added, we do the fine tuning process over again, just to help it get more data and thereby more information, more accuracy that way. Yeah. So I believe that's it. Thank you all so much for your attention.